Bob Bennett, you're the guy that's responsible for the quality of what we get out there in TV land. You've got an extremely complex system that probably we could spend the next 17 years explaining to us, and then we still wouldn't understand it, all of it. Can you hit the highlights and show us what it is you do here on a... It's a 24-hour day for you, isn't it, really?
Yes,
this place never shuts down.
No, we never do shut down, and as most of your people are aware, Vernon Valley is supplying a large number of the cable TV signals that are presently on the F-1 spacecraft. We have a total of 6 at the present time. We have the 3 HBO signals, the 2 Showtime, and a 4th HBO, which was just recently placed in service. Okay, the main idea of the entire station is to supply broadcast quality video plus audio and message traffic to the customers throughout the United States, both RCA facilities similar to this one and also to the cable TV industry. The signals are brought to Vernon Valley in 2 ways. Either they are brought via microwave to Vernon Valley from New York City, or they are originated within the facility in our video tape center, which you have previously seen.
Well, maybe not previously to this, but we will see it before we get done.
We'll see it before the end of the day. All the signals that are passing through Vernon Valley appear at this console. All right. The reason for that is to allow the communication technician who's on duty to have instant access to the signal to check it for both quality and continuity. From this location, he can monitor both video and audio. There are black and white line monitors which are constantly online, which are located here and here. In addition to that, there are a 650 color monitor which allows him to scrutinize the signal even closely if he suspects any problem. Also at the same time, there is the standard variety of video test equipment, vector scope, and waveform monitors so that we can analyze a signal that is in actual programming.
I might add that we've asked the fellow who's normally sitting right here to move off to the side, and at the moment you're the guy in charge in addition to taking us on this tour.
Hopefully nothing's going to go wrong.
It couldn't be in better hands, sir.
Yeah. All righty. Where we're going to go to now is that with any system, time is important and communication is important. So we have our own individual communications facility, which is dedicated to, through the satellite, to all the other RCA-owned facilities throughout the United States that are a part of the RCA Americom network.
This is your own private telephone system, if I can say it that way.
Right. Yes, that's exactly what it is. It's called an AutoWire. We use it to troubleshoot problems in relation to video and also to initiate carriers and so forth on the satellite, and to troubleshoot any problem that would arise in the event of an in-progress programming or so forth. We then go from the AutoWire to the main part of the communications console, which is the monitoring system. The equipment necessary to support communications at Vernon Valley is not just in the communications room. It is spread throughout the facility. A little later on we're going to go into the HPA room, but that is in another area of the building. So therefore we must have a system so that we are aware of the condition of all the equipment associated with the transmission or reception of signals at Vernon Valley. This is done through what we call a mimic panel, and this is what is contained in the center of the console. What it does is that it monitors the status of all the equipment associated with the uplinks and downlinks within the facility, and in the event that a piece of equipment were to fail, 2 things occur. A automatic switch over to a backup system which is sitting online and ready to go, which is frequency agile, will be switched online immediately to restore the service to the individual facility that has failed. The second thing that occurs is that an alarm is sounded for the technician that a failure has occurred. The green light status on the console for the piece of equipment that has failed will change to red, and also a summary alarm indicating which major subsystem has failed will appear on this console right here.
Antenna, LNA, HPA, I'm reading off a summary alarm lights. There is no aspect of your uplink terminal here that isn't monitored from this panel. Is
that is absolutely correct. Plus, all the facilities within the building are also monitored. The condition of the power system, the generator status, the waveguide pressurization system, which is pressurizing the waveguide runs to the antenna. Everything that is necessary for communications within the facility is monitored on this panel.
Okay. I think there's a piece of gear coming up here that every cable operator will recognize as a spectrum analyzer, and it has a particularly interesting display. So we'll move over to that facility now and let you explain to us how you visibly keep an eye on all the transponders at all times.
Okay. You ready? Okay. From this spectrum analyzer, which you see in front of you, the technician at Vernon Valley, by means of a flip of the switch, can see either polarization, the odd or the even polarization of either the F1 or the F2 spacecraft. At the present time, we're looking at a display of the F1 even side, which is the present facility for the cable TV industry. As you can see, there are an awful lot of signals there for us to keep track of, and as a matter of course, there are certain days and times that things get pretty hectic around here. As you know, or if you don't know, Vernon Valley is control for the network, and therefore have the responsibility of monitoring not only the signals that are generated by the RCA owned facilities, but also monitoring the performance to preclude any type of degradation of the customer-owned facilities also.
Let's stop there just a second. We're saying PTL, we're saying CBN, we're saying anybody who uplinks starting at a site that is not an RCA owned and operated uplink site. You have the additional responsibility of checking the quality of that uplink signal full-time, 24 hours a day. Were something to go wrong, were there polarization integrity to slip or something like that, you see it here, and then what happens?
Well, what we do at that point in time is that we attempt to coordinate with the customer-owned facility to rectify the problem as soon as possible, and to maintain the highest quality service that can be available. And if we can add technical assistance, we do, but in most cases these people are fast to respond if there is any question as to their performance, and cooperate in every aspect to help us out, and also to assure a high quality signal to their customer.
Can we move in here perhaps in a way that allow us to let you do the flip through of the vertical and horizontal transponder channels on this spectrum analyzer? Can the camera get in a little tighter here perhaps? And it's a kind of a fascinating display that not too many cable operators would have the instant opportunity to look at, since we're going to look at two birds and two polarizations simultaneously.
Right.
Why don't you go ahead and tell us what we're looking at?
Okay, at the present time we're looking at the even side of F1. We were going to take and we're going to flip a little switch here. Now we're looking at the odd side of F1. At the present time on the odd side of F1 you can see our message carriers. That is also slated for some in the nearer immediate future for expansion for the cable TV industry.
Go ahead. I was going to ask what the carriers that are well down are. Is that the opposite polarization?
That is the opposite pole. That what you're seeing there is some cross pole coming through from the opposite polarization.
Of course, you've got a great deal of dynamic range on this
spectrum analyzer. Right. Also, the fact that it's raining outside here at Vernon Valley, we are getting some degradation due to lowering of the cross pole isolation due to the rain that is presently around, as you are well aware of.
Yes, it's kind of wet.
Kind of wet.
All right, now on to F2, I guess.
To go to F2 is just a matter of we're going to go to the odd side of F2, and there we are.
Very busy.
Very busy. That basically is one of the reasons that the cable TV industry was moved. As you can see, there is no room for expansion on the odd side of the F2 spacecraft, and since your industry is growing so rapidly, we have chosen to go to F1 to give you the additional capability on the odd side.
Now, some of the carriers are very stable, and yet here's one, two, another one over here that are moving around a bit. What does that indicate to somebody looking at a spectrum analyzer?
What that indicates is this carrier is not fully loaded. What I mean by that is that this would be normally, let's say, a 1,000 voice grade channel carrier, and that's energy dispersal on there. And what it is doing is dispersing the energy through the total bandwidth of the transponder. As that carrier loads up, or more of those voice circuits are being used at peak periods during the day, the amount of dispersal will decrease and the carrier will appear more like the carrier that you see right here.
Okay, from vertical F2, which is where we are now, to horizontal F2, right.
There we go. There's horizontal F2, and same thing is true there. We're looking at the message carriers on the F2 spacecraft. The empty holes, of course, are the spaces vacated by the cable TV industry.
All right, and is this again the energy dispersal waveform modulating that carrier?
Yes, that's effectively what you're seeing there. As you can see right here, this is a video carrier. You can see a little bit of dispersal on the video carrier, but it's more predominant right on that specific carrier right there.
All right, all right. Let's pull the camera back a little bit, and you've got your next segment of this panel deals with the transmitter monitoring. Is that correct?
That is correct. As I mentioned before, the transmitters are not physically located in the communications room, one being they're very noisy, and secondly, they're very hot, and it would be more like the black hole of Calcutta in here than a air-conditioned computer-type environment if they were located within the communications area. So what we have here is remote control units for our transmitters. What we can do from this location is we can raise and lower power on any transmitter within the building, and we also have the capability of initiating a carrier from here. We can turn a transmitter on and off, raise and lower its power, and also at the same time we can monitor the status of that transmitter. It has a fault summary circuit which will alert us to any possible problem with the transmitter by illuminating a red light and ringing a bell or a whistle on the individual transmitter that is in trouble.
How many transmitters are we talking about out of this facility that if you had ever one of them turned on,
well,
what kind of number?
What kind of number we're talking about right now is that presently we have 11 transmitters within the facility, 9 of which are being used for communications. 2 are dedicated to commanding, or specifically for command uplinks to support the spacecraft operation.
All right. Is there anything else in this particular segment of the control room that we ought to look at, or should we move into the HPA area?
Well, I'd just like to mention one thing. We're sitting here and we're looking at this little black panel here that's got the little red light illuminated on it. That is the monitoring system for the microwave link. Vernon Valley and the Earth Station, for continuity and our ability to respond to a problem, we maintain and operate our own microwave link from Vernon Valley.
How many hops is it, Bob?
It is comprised of, it's a 2-hop system or a 3-hop system between here and New York. We have 2 intermediate repeaters that are unmanned between here and the 60 Broad Street location. The monitoring system is constantly scanning all the remote locations, monitoring all the equipment within the facilities. In the event that a specific piece of equipment were to fail, there is redundant systems throughout. Would switch the backup system online to maintain the traffic, and then a number would be illuminated on this panel indicating that a specific piece of equipment has failed, and then we would dispatch a technician from Vernon Valley to the site to repair the problem. The 19, which is illuminated right now, is telling us that the aviation lights are on at the tower at the repeater site, which is approximately 3 miles from here.
And encased in clouds and fog at the moment. That probably is the reason.
That is definitely the reason that it is illuminated right now, is that the tower is sucked in 100% at the present time.
This morning when we first looked at this, there was, I recall it was the number 14 under the New York column, and you showed no concern at all, and then you explained what it was. And I'd like you to tell me again, because it shows I think the degree of security you've built into this system.
Well, what the number 14 meant was that I had some people working in New York, and it said that the door was open and that there was somebody within the facility working at the present time.
You don't leave much chance, do you?
No, we don't. We try to think of everything, or at least we attempt to. Why don't we, at this point, move on into the high-power transmitter room, which I call my plumber's nightmare.
Every ham radio operator in the audience, pay close attention. This is a dream rig.